Thank you for joining me for another episode of Empower Apps. I'm your host, Leo Dion. You can find me on Twitter at LeoGDion. My company is Bright Digit, specializing in development in the Swift space. You can find my company at brightdigit.com or on Twitter at brightdigit. With us today, we have Jameson Toole from FritzAI. Hey, Jameson.
How's it going? Thanks so much for having me.
Really glad to have you on. Really glad to tackle the subject of machine learning. Again, we had Kevin on last year, and it's really awesome to have somebody from FritzAI, some of the best resources online for Swift developers getting into AI. Any developer, is some of the stuff that you guys put out, and it's been fantastic.
Thanks so much. Yeah, I appreciate you checking out our content.
Tell me a little bit about yourself.
I guess I would describe myself as a reformed physicist. I started out as a physics major a long time ago, but I got really interested in the modeling side of physics, less interested in the sort of electrons side of things. And so over the years, I started looking at what other things could we model using the types of statistical techniques that came out of physics. And this was, a little over a decade ago when big data was really starting to come into its own, and we were realizing, how much information is out there being collected from web applications or smartphones. And so over the years, I kind of moved in from physics to data science and then big data, machine learning, and now, deep learning and artificial intelligence are really the tools of choice. And along that journey, I sort of picked up software engineering skills because, my ultimate goal is to get my models out into the real world where people can use them and interact with them. And, there's a lot of things that go on outside of just the ML and AI pieces to actually build an application or a product or an experience around those models.
Very cool. Explain exactly what it means to build a model.
Got it. There's a couple different levels that I think about this on. There's sort of the micro level, which is the actual architecture of the model itself. While it may be intimidating to a lot of people when they get into machine learning or AI to begin with, the base level operations of a lot of these models are actually very simple. You're multiplying matrices together, you're adding matrices together. And so when we say build a model, there is an architecture associated with that, which is really just a number of these simple operations, the order that they are connected. And that really defines the type of data that goes through and then what comes out. There's a higher level concept that we should talk about as well, which is really thinking about the task that you want your model to perform, whether you want it to label images as cat or dog, or remove the background noise in an audio stream. Those are very high level tasks that you need to define ahead of time. And that informs a lot of the choices that you'll make around the data that you need to collect, the way that you will train a model or teach it to perform that task, and then even down into which operations, those little micro level building blocks I talked about, you'll need to use.
Well, let's talk specifically about prepping data, because ever since I started my software development career, prepping data has always been a big part of that, because you get some crappy Excel file with all sorts of junk in it. And even without the machine learning, you have to prep data in some way or to get it into a database. That seems like a big challenge with machine learning, is just getting your data to work correctly. That seems like the case as far as what I've seen.
Yeah, data prep is, the most important step of machine learning. If you don't prepare your data and understand it, you're going to sort of put garbage into your model and it's going to produce garbage for you. So, there's all of these adages like, you spend 80% of your time as a data scientist or machine learning engineer just cleaning data. It's not as glamorous as everybody thinks it is, but it's really important. There are a number of steps that I like to go through every time I get a new data set. And, we can certainly talk about them if that's interesting. But, if you're just getting started with machine learning project, you want to spend, I think, the majority of your time looking at your data and really understanding what you're going to need and how to get the highest quality data possible before you start worrying about all of the other pieces of, well, do I use a neural network or something else?
Hey folks, I wanted to let you know about the host of our podcast, Transistor FM. Transistor has been an awesome podcast host for the last 2 years I've used it. And what I really like about it is all the great features it offers people who want to really run a professional podcast. I love the automated integrations with Apple Podcasts, Google Podcasts, Spotify, MailChimp, etc. They offer really great analytics, which I use quite frequently. And they have updated their UI to look fantastic and be usable on the iPad as well. One thing I've been thinking about lately with a lot of the stuff in the news is the importance of running a independent podcast. We all know about stories about YouTubers and app developers running into issues with all sorts of gatekeepers. And one of the places where we have that kind of independence is in podcasting. Unfortunately, there's some hosts which can have an inordinate amount of control over your podcast and act like a gatekeeper, like many of some of these other companies that we've been hearing about lately. Things like ad insertion or control over how your podcast is published and broadcasted. Things like that if you're running a professional podcast is either risky or can lower the quality of your show. Something about Transistor is that you own the podcast, it is yours, and you have that complete independence. It works on multiple platforms, so you're not locked down to someone like Spotify, for instance. You have a completely open RSS feed, but also they have a lot of tools to help you run a professional podcast as well, like the analytics, but also things like being able to have a private RSS link if you want to run some sort of membership service along with your podcast as well, or you want to be able to only allow certain people to listen to your show, which I think is awesome and a really great feature. So again, I highly recommend checking Transistor out. Let them know you heard about Transistor from us. Go to the link in the show notes below to give Transistor a try today for 14 days. Yeah, well, let's go into that a little bit more in depth. Like, what kind of things do you have to do to prep your data?
Sure, that's a great question. So it all starts with defining that high-level task that you actually want to perform. And this may not seem related to data, but it actually is very closely tied. So there's a lot of different terminology for everything in machine learning. And just to take a sort of subset of common use cases, let's talk about some computer vision tasks like image recognition or object detection. Those two things are actually two very different tasks. So image recognition, for example, would take a picture and then try to label it as cat or dog or whatever's in the photo. Whereas object detection is a different task where you are actually looking at that image and trying to localize an object within the image. So put a bounding box around it and then predict what is in that bounding box. So it might still be cat or dog, but it's a different task in that we want to actually locate it within the image. You need to know ahead of time before you start collecting data, because in most of the machine learning that we're probably going to be talking about today, we're going to be doing something called supervised learning, where we actually have to show a model during training the input data and then the answer that we want it to produce. And that answer that we need to have ahead of time is going to depend on the task that we're going to perform. So the worst case scenario here that you see sometimes is people will come in and they'll have a bunch of data and they've labeled all of their images, thousands of them as cat or dog, but it turned out that they wanted to actually do object detection, not image recognition. And so they actually need to go back and start relabeling all of their data and actually drawing those boxes on the screen to make that an appropriate data set for the task that they're trying to solve. So the first step here for prepping your data is to really understand the task that you want your model to perform, the output that you want from that model. Because in the case of supervised machine learning, you're going to need to get your inputs and then actually annotate your data and label it with the things that you want the model to predict.
Well, let's break down the different types of tasks machine learning can do. And it seems like one of the big differences is between recommendation engines and recognition engines, correct?
Yeah, so those are definitely two very popular tasks that we see a lot of today. A recommender engine is essentially going to take some input, which could be some information about a user, maybe their demographics, maybe their past purchases or past behavior, and it's going to try to recommend new things to them. This is usually based on some sort of similarity with the types of things they've done in the past and the types of things they can do in the future. You may also look at similar users and try to find overlapping sets of things for them to do. Whereas a recognition task would take some piece of data and try to classify it as one or more things, right? This is different, though, than the actual method of machine learning that we're going to be using. So, for example, I mentioned supervised learning. Those are cases where we actually have raw data and then we have the exact thing that we want the model to predict. You can train a recommender system and a recognition system with supervised learning. There's another type of machine learning that we do sometimes called unsupervised learning, where we don't actually have the labels. We don't have the answers that we want the machine learning model to produce for us. And so you see this come up occasionally where you just want to cluster users based on their behavior, as opposed to having a predefined set of classes that you want to assign a user to. So you can mix and match these different ways of framing the problem with the different actual model types, depending on your use case.
So with recommendation, you don't really need to supervise it. It's usually just a table of data that you submit and create a model based on.
Yeah, so I think there are a lot of recommender systems that actually do require supervision in the context that we talked about previously. And so with recommenders, supervised learning would say, I have this user and I'm going to take a subset of their behavior and use it to predict something else they might buy. But you might hide some fraction of their purchases, for example, from a model. And then the supervised learning will say, the goal of the model during training is to predict these other purchases that we know the user actually made based on this unhidden set that we're showing the model. An unsupervised setting would simply say, here's everything that the user has looked at in the past. Let's cluster all of our users together based on that information, and then just look for maybe items that users in this person's cluster bought, but this particular user hasn't bought, and that's what we'll recommend to them. It's not like you can only use supervised learning or only use unsupervised learning for any given task.
Gotcha. Okay. And in the case of what Apple provides when it comes to their API, I would assume then that their recommenders, I guess it depends on how you apply it, whether you're going to, well, no, I guess it would be unsupervised in that case, right?
You can actually do both.
Okay.
So, Apple does provide high-level APIs to train recognition models as well as recommender models. And you can use the data that you have. If you don't have any ground truth data on what users are purchasing, you can use an unsupervised model. Otherwise, you can use the supervised model.
Let's talk about one particular API that is really popular in machine learning when it comes to Swift, and that's the vision framework, which offers a wide variety of tasks, correct, as far as what you can do when it comes to visual data.
Yeah, so the vision framework that Apple provides in iOS is really, really powerful. And, computer vision in general, I think, is certainly the most popular today type of task that we see mobile developers wanting to perform. And this makes a lot of sense, right? Mobile phones have really always been about the camera. And there's just been such incredible technology put into what are now multiple cameras on our phones.
Right, exactly.
And so it's no surprise, right, that a lot of the cutting edge machine learning has been developed to make use of and augment that visual information. So Apple provides a number of what I would call pre-trained or pre-packaged models that are built into the operating system to do common general tasks. So for example, identifying text in photos, drawing boxes around that text, and then actually parsing what is written inside those boxes. They provide some human pose estimation to identify common key points on a person's body, their elbows, their hands, their eyes, their nose. They've just released, hand pose estimation as well in the latest versions of iOS, so you can detect where fingers are in images or live video. And so, all of these things are really meant to take advantage of the camera and provide additional contextual information that developers can use to build experiences.
What other popular purposes do you see around using the vision framework?
It can range from creativity tools, so using the content of an image to create filters and effects. So for example, pose estimation, you might be creating some augmented reality experience where a person can move their body in some way, and that will affect the images on the screen, or maybe you can put a suit of armor on them or some sort of fun effect like that. You're also seeing things like artistic style transfer, which is something that CreateML has some ability to train. That produces artistic effects that you can apply to images or videos. We see a lot of really interesting applications in that creativity space, green screens, background removal, all sorts of things like that. There's also a lot of really great use cases in specific industries, like, for example, e-commerce. So, doing visual search using machine learning models, so you can take a picture of a cool pair of shoes that you see on the subway, and it will automatically identify that pair of shoes or show you shoes that are visually similar to it. Doing home try-on. So, right now you might not want to go and actually step into a store to try on a pair of glasses, but you could use the facial recognition models within iOS to identify, where a person's eyes and ears are, and then build an experience where they can actually virtually try on a pair of glasses right from their phone. So all of these things are enabled by the computer vision models that are, being built and actually implemented in the operating systems.
So we've talked about vision. I think the next big thing is dealing with speech and text. Well, specifically, let's talk about text and like natural language. What kind of tools does Apple provide for being able to like decipher or like do things with text using machine learning?
Whereas vision really dominated the last 5 years, I would say, of machine learning and AI research, I think natural language is going to be the next 5 years. There's been some really incredible breakthroughs in the underlying technologies for how do we actually build models that can do useful things with text. On the natural language side, there are some built-in models that you can use to perform some tasks. These are very general tasks, though. So things like what's called named entity extraction. So can you take a piece of text and extract all of the proper nouns, so names of companies or sports players, that sort of thing? Doing basic translation between languages, identifying what language is actually on the page so that you can provide different options for people. That sort of thing is really baked into the operating system at this point. There are a number of breakthroughs that have been made, again, on the research side of things in the last couple of years to do more complicated tasks. So could you read an article and summarize it automatically with a model? Can you take an article and ask a question to a model and have it actually return an answer to that question based on some corpus of text that it has learned from? These are more advanced tasks that we are starting to perform better than humans with these machine learning models. So you may have seen in the news, these model types are known as transformers. There's really large ones trained by organizations like OpenAI. They have one called GPT-3 that is making waves right now in the news because it's so large and so powerful. But what we are learning is that we actually need to do some work to make these models small enough to run on a device. So right now, all of the large natural language processing models that have come out in the last few years are just way too big to run on a phone. Tens of gigabytes worth of parameters. It needs all this RAM and CPU. But we're getting better at shrinking those models down to the point where you can actually package it up within an app and run it directly on a phone. And so I think over the next few years, you're going to see a really big explosion in the amount of things that you can do with natural language processing right on someone's device.
Well, let's talk about that a little bit, about machine learning on a device versus in the cloud or on a server. What are benefits to one over the other?
Yeah, so there's a bunch of them, and it won't be a surprise that we think the benefits are so great that we started a whole company around it. But the first and foremost, it's really about latency. So if you're doing any sort of real-time application with real-time video, audio, text, that sort of thing, waiting for your data to be transferred from a user's device all the way up to the cloud, processed there, then back down to the device again, is just too long for a large variety of applications. So, imagine that you're using Snapchat, and to just try out a new filter, you have to send your video all the way up to the cloud, have them processed there and have it sent back to the device, it could take 30 seconds, a minute, a couple minutes, depending on how long your video is. No user is going to wait that long to just try out a new filter. And so if you want to do things in real time or near real time, it has to be on the device itself. The other big benefit that you get from moving down to the device from a user experience perspective is around connectivity. There are a lot of very nifty machine learning apps out there. And I always like to test, do they still work in airplane mode, right? Or are they using all of my data plan to send these images or video up to the cloud and back? And so when you put it on the device, your app functions the same regardless of your connectivity. And then the other two big things that I like to talk about are user privacy. Privacy has gotten a lot more pushed to the top of the discussion in the last few years, rightfully so. And I view on-device machine learning as a way to finally provide these ML-powered experiences that we all really love, while also making good on promises of privacy. So instead of taking a user's data, transferring it to the cloud to run machine learning on it, we can take the machine learning model and actually push it to the user's device so that their data can stay there literally in their hands. And then the last big thing that we think about with on-device machine learning is actual cost. So if you're running a business right now and you want to use some of the latest and greatest ML models, you're going to need to provision some pretty expensive hardware in the cloud. These GPUs or even more expensive accelerators are not cheap. And so running an ML service in the cloud is no small task. And so if you can offload some of that processing down to a device that's free to you, it's a much more viable way to build machine learning and deploy machine learning features.
Very cool. Yeah, I mean, the user privacy one was the one I've always thought of, but it's really interesting, just the technical limitations of having a server, and it sounds like financial cost as well of having a server do that might be prohibitive.
Yeah, certainly. And you see this more frequently than you might expect, where companies think of a really great use case for machine learning and they release a press release about it and they really hype it up. And then when it comes to deploy that, they realize that their cost model doesn't work. And so they have to start charging add-ons or limiting users, based on keeping their own costs in check. And so by pushing as much down to the device as possible, you can really get around a lot of those limitations.
So we talked about natural language, that is text. But how about speech? For instance, I obviously am running a podcast here, and on occasion I'll transcribe our episodes. And so I've definitely seen leaps and bounds in that area, but it seems like speech and sound stuff seems to be growing at a ever faster pace when it comes to the machine learning abilities that we have now.
Yeah, definitely. So transcription, both ways actually. So taking speech, translating it to text, taking text, translating it to speech have really been sort of the core use cases for a long time now. Specifically, when it comes to on-device machine learning, there's really been a breakthrough in the last couple of years where we are able to shrink these models down and run them completely on device. So here we're talking mostly about iOS and Apple, but Google was actually the first to do this, where about a year ago, they announced that their speech to text model, which they use for their assistant on the Pixel phones, had been moved to entirely run on device. And, they could then provide extremely low latency, and they could provide that service in connectivity denied environments. And their accuracy was actually better with this fully on device model than it was with their previous model, which was cloud-based. And so then you've sort of seen a rush to push more of the speech processing, whether it's in Siri or an Alexa device, down to that device itself, so that you don't have to wait, for the audio to go back and forth.
Yeah, so one of the services I use is Descript, and they now have an ability to do speaker detection and audio editing, all sorts of really interesting features. It seems like there's a big growth in that as well when it comes to machine learning and sound and speech.
Yeah, so we're really learning, I think, to combine, different types of models together to form these more powerful user experiences. So whereas before we might have just done transcription, now we can actually do transcription, but then also ascribe each phrase to the specific person that was speaking at that moment, and then even, pull out key phrases or triggers for action items. So if someone says, "Oh, I'll follow up with you on that next week," a machine learning model could automatically detect that and send a calendar invite for you, or summarize the call with all of these action items pulled out. So we're getting much more sophisticated in terms of the actual user experiences that we can build around these models.
And that seems like a big part of the formula for like a good voice assistant. Because we hear the occasional complaint about Siri. But I think like one of the issues with Siri is it has to listen on a variety of microphones. And like it has to be microphone agnostic, so to speak. And it has to deal with sound quality as well as being able to interpret what people say. And I feel like that's a big challenge with Siri.
Yeah. And the way that I see machine learning interacting with these sorts of things is in the past, a lot of these problems were only solvable via hardware. So you need to add more microphones, higher quality microphones, that sort of thing. But as we move forward, the machine learning models are getting better and better to the point where they can replace that hardware with just a machine learning model. And so it can automatically detect more things or clean up audio for you. And that's kind of what we've seen with the frontier of all of these new machine learning models.
So it's that time of the year you're probably trying to build that brand new app for iOS 14 that you want to get out in time for fall. But one thing you should probably think about is how are people going to find this new app? You could try to rely on your social media feed, but it might be a good idea to take a look at App Store optimization. And that's where Appfigures comes in. We've talked about Appfigures before on this podcast, and we've had Ariel, their CEO, on the show, talking about how you can optimize your app for the App Store. And they've just released brand new ASO teardowns, which have taken a look at some of the big names on the App Store, but also looked at some indie apps like Fotmob, which I'll have a link in the show notes below. These teardowns take a look step by step at what these apps are doing right and what they're doing wrong to get their name out on the App Store. And just recently, they've launched a brand new competitor intelligence report, which is live right now. These new competitor reports from Appfigures give you the ability to see competitor downloads, build performance benchmarks, and see new trends as they happen. You can see it in action by clicking the link in the episode notes below. So go ahead and give Appfigures a try for free. And if you like it, use our special code EMPOWER3030 to get 30% off for the next 3 months. Again, just go to appfigures.com and try it for free. Use our special code or the link in our show notes below to get 30% off for the next 3 months. I want to thank Appfigures for sponsoring our show. So let's talk about actually using machine learning on a project. What are some considerations to make when you're starting a new app or a new software project where machine learning might be a good fit that people usually don't think of?
Yeah, that's a great question. So we talked about the importance of finding and creating high quality data sets. That's going to be important for any project. I think one of the areas that we commonly see people that are new to machine learning struggle in is actually sort of debugging and iterating on their models and understanding why they fail and what to do about it. More traditional programming, right? If you write a bug or do something that's incorrect, eventually, you're going to throw an error, and there's going to be a stack trace that tells you, sort of exactly which line the error was on. And in most cases, it's going to be pretty descriptive for what the issue was. Machine learning is really nothing like that. The failures are much more silent. The model will not complain at all. You've put an image in, but the results that it's producing are sort of garbage, right? So it's misclassifying things, or it's just classifying everything as the same thing. But there's no stack trace there, and there's no error or exception that gets thrown. And so people that are just starting projects need to think very carefully about how are they going to actually monitor these systems and identify that they are truly working. And when they're not working, they need to make sure that they've instrumented them so that they can go back and identify, here is the data that's going into the model. Is that what we expect? Here's the data that's coming out of the model. Is that what we expect? If the model is producing predictions that are very far outside of what we would want, do we have a fallback to show the user if there's a failure here, in the same way that you would catch an exception and change the behavior? All of that kind of needs to be reimagined when you're doing any sort of machine learning project.
It almost sounds like an iterative, unit testing type thing, where it's like you have a dashboard set up to fix corrections, and then you iterate over the model at a regular, interval of some sort.
Exactly. This is one of the core concepts that I always make sure to try to drill into people's heads when they're getting into these machine learning projects, is that it's people come in and they think, okay, I'm going to train a model and eventually it's going to detect dogs well enough and that's going to be it. And then I can go on and build the rest of my app and the model will work forever. And that's really not the case. It's a very iterative process. You're sort of never done, because your users will find very interesting edge cases, or you'll find out that you trained your model on images from bright sunny days, but people are actually using the app in dark restaurants or something like that, and it doesn't work at all. And so you need to constantly be looking at, here's what our users are doing, and is the model actually trained on that type of data.
So if you're starting a brand new app or a brand new software project, how do you acquire that initial set of data that you need?
This is known as sort of the cold start problem with machine learning, where everyone's bought in, you've got this really great idea, you think it can be solved by machine learning, and you immediately hit this wall of, oh no, we don't have any data here. There's good news and bad news. The bad news is that you do need some data. It's got to be high quality, and in some cases, it is going to require that you go out and take some images yourself, or build a little scraper to grab the data that you need, and you might have to do a few hours of annotation by hand. But the good news is that, I think you don't always need as much data as you'd think to get your first version of your model working. And then you can kind of bootstrap it from there. So you can go and collect a few thousand images, label them, train a model, and then use that model to pre-label the next 1,000 images. And maybe you only have to fix a few of them for the next step. So there's a lot of interesting techniques that you can use to bootstrap things. The other big breakthrough technology that I'm really excited about in machine learning is something called synthetic data. And this is something that we've implemented in the FritzAI platform to really accelerate people's process to getting their first version of their model created. And so the idea with synthetic data is that we've actually come up with a lot of really great tools to produce data that is good enough for the model to train on. Without actually, we can produce this programmatically. So for example, if you wanted to detect soccer balls, say, in images or videos, one way of doing that would be going and collecting by hand, thousands of images of people playing soccer and then drawing rectangles around all of the soccer balls in those images. But with synthetic data, you can actually go out and grab some representative set of a few dozen of those images and then use traditional image compositing techniques to paste images of soccer balls or people playing soccer onto randomized backgrounds, and you paste them in random positions. And you can change the contrast of photos or add noise into them, using all sorts of traditional computer vision algorithms that you have in tools like Photoshop, or you can do it programmatically with Python. And you can actually generate thousands of images that are all different in all sorts of configurations. And the important thing here is you can also generate the crucial annotations. So because you're doing this programmatically, you know exactly where the soccer ball is on every image that you generate. And this is a really great way to get started with machine learning, where you don't actually have to invest hours and hours of time collecting and labeling data yourself. You can just generate it.
Could there be issues with synthetic data, like just kind of creating a feedback loop in the machine language model you create?
Certainly. So, the way that I always try to describe it is, your goal with synthetic data is to make sure that what's coming out is as representative of the use case, the real world data as possible. So there's, again, this constant iteration of looking at, okay, here's the data that we're producing synthetically. Here's the data that we expect users to be passing into the model. And you want to make sure that those match. One thing I should say, though, is that we've actually learned that in some cases, having synthetic data that looks very different from real world use is actually helpful to the model. This may be getting in the weeds of some machine learning research, but there's a technique known as domain randomization, which has found that if you show the model a lot of random, confusing looking things, it will actually do a better job of distinguishing what is just the background of an image from the actual subject that you're trying to get it to recognize. You don't have to make your data perfect, your synthetic data perfect, but as long as it's sort of capturing the essence of whatever subject you're trying to identify with your model, it's a really powerful tool.
The other concern that like a lot of folks have is architecting an app and building it out in a way that's easily testable. What are some ways to do that with machine learning without making it too cumbersome?
What we've done is, it is possible to unit test in the same way that you would a sort of regular function. But the name of the game here is to make sure that you understand sort of exactly what is going into your model when you're doing this type of testing. And you have a very good idea of what is coming out. So, for example, if you wanted to test an object detection model in your app, you can have an image, you can run it through the model, and then visually inspect that the model is actually producing results that you would want. And then, you're sort of hard coding in your test that, okay, we expect this image to come out of the model with 4 boxes roughly in these locations. And you can put some fuzzy sort of heuristic logic in that unit test. And that way, if you change your model at a later date and it all of a sudden isn't working well and it's not predicting these 4 boxes, your unit test will alert you to that. The other things that you really want to consider when you're architecting your app is that these models can be large in some cases. So even with all of our most advanced optimization techniques, sometimes your model can be dozens of megabytes, right? So 25, even up to 100 megabytes for some of the larger on-device models. And as an app developer, it's very important that you keep your bundle size as small as possible. And so there's a trade-off that you're going to have to make between the performance of your model, the accuracy of your model, and how large it is. And so that's one thing that developers should keep in mind. The other thing is keeping in mind where that asset is stored and how it's updated. So CoreML, for example, gives you the ability to download new versions of models over the air. So you actually don't have to package them in your application. You can download them after a user has signed up, for example. And so thinking about what's my user experience going to be like if I have to wait for someone to download a few hundred megabytes of a model, what's going to happen when I update that model? I want to make sure that I don't download that automatically when they're using cellular data, for example. Because that would not be a great user experience. And then the last thing that you sort of need to consider when building one of these apps is where your model is actually going to run. And so what I mean by that is you have nowadays 3 different choices of hardware that you can run your model on. You can run it on just the CPU. This is going to be the slowest, but it's usually the most energy efficient in some cases. You can run things on the background, on background threads on the CPU. You can also run things on the GPU. This will be much faster, but it's sort of the least energy efficient. And then on most newer devices, you have access to what are called neural processing units, or in the case of Apple's systems, you have the Apple Neural Engine, which give you really high performance and actually very good energy efficiency with the level of acceleration. And you can choose in your application logic where you want to run those models, or you can let the operating system decide. But depending on trade-offs around memory usage, around energy efficiency, you might want to push your computation to different processors.
Speaking of Apple's processors, one of the big announcements from DubDub was the migration of Apple's Macs from Intel to their own Apple Silicon, which is heavily invested in neural networks and machine learning and things like that. How do you think that'll affect app development, particularly in the machine learning space?
It'll be interesting to see how this plays out. I don't think we quite know enough yet, but in the world of iOS devices and sort of the current generation of like Mac OS, CoreML is not the only, but is probably the most popular way of running these machine learning models, and it can take advantage of some custom silicon from Apple, like the Neural Engine. What's interesting about the latest releases at WWDC is that they introduced this new framework called ML Compute. And this is sort of completely separate. It's another path from CoreML. And what I sort of see this as is a very low-level library that other machine learning frameworks are going to need to wrap in order to actually get hardware-accelerated machine learning running on the newest generation of Apple Silicon. So, for example, a framework like TensorFlow or PyTorch is a very high-level machine learning framework. And those frameworks allow you to build various models, but they rely on low-level operations that are implemented specifically for different chips. And to run like a convolutional neural network, for example, TensorFlow uses, when they're using NVIDIA graphics cards, it will use very low-level libraries provided by NVIDIA specifically designed to map those high-level operations onto low-level code for their GPUs. And so Apple, I think with ML Compute, is going to need to provide a way for a library like TensorFlow, which is what developers are using, to actually leverage the hardware that they're building. And so until they do that, it's going to be really hard to do a lot of large-scale machine learning on the new hardware.
Interesting. What other things came out of WWDC that you think are going to change the way we do machine learning on devices?
Yeah, so there was a number of really interesting announcements there. I think in terms of the forward-looking, really big breakthroughs, there were two that I think are worth talking about. The first is just much more support for pose estimation via the operating system. So in ARKit 3, in the previous version of iOS, Apple had added human pose estimation, which was, I think, 17 points on a human body they can detect. So eyes, nose, knees, elbows, that sort of thing. They've added additional support for hands. And then on top of that, they've built out an activity classification API where you can actually feed Create ML videos of people performing various actions, push-ups, sit-ups, pull-ups, that sort of thing, and train a model to detect what action people are performing. And this is very common in machine learning where as soon as we sort of solve one problem, like sort of generic human pose estimation, we start thinking of, well, what can we hook that model up to? And the output of one model becomes the input of a new model. And so with something like activity classification, you've got video going into a pose estimation model, the poses that are output from that going into an activity classification model, and the output of that is the actual classification. So it really just becomes a game of combination at that point. So that was really neat. And then the last thing that I think is worth pointing out about WWDC from an ML perspective is actually nothing to do with the ML itself. It's something to do with the sensors. So ML is all about data. And so whenever you get a new source of data, you get a new set of possibilities for ML. And so you saw this with the most recent iPads that were released, but the inclusion of LiDAR directly in the device, which I assume will come to more devices in the future, gives developers and ML practitioners a totally new set of data to start training models on. So, to date, we've had cameras which produce 2D images with, pixel values for all of the points in that image. The LiDAR gives you these point clouds in three-dimensional space, and it opens up a whole new class of problems that you might want to solve. So identifying objects in 3D space, doing path tracing, that sort of thing. And because those point clouds are sort of different from images or sound or text, it's going to require a whole new class of models to actually make that data useful.
Cool. Well, thanks for coming on the show, Jameson. Very informative. I really enjoyed it. What are some good demos or tutorials people should check out if they're interested in learning more about machine learning?
So I think, certainly Apple and Google have put out some very impressive demos for leveraging machine learning on device. I also have to give a plug to FritzAI, which, we've from day one, really tried to build a community around people that are doing on-device machine learning. And so we have a whole bunch of great blog posts and tutorials at Heartbeat, which is our developer community blog. And then we also have some open source tutorials, applications for both iOS and Android to use some of these models that we've talked about, like pose estimation and image segmentation, so you can get your hands dirty with all of the interesting things that these devices can do now.
Awesome. And where can people find you online?
So you can find me at Jameson the Crow on Twitter, and then at Fritz Labs if you want to follow the latest in mobile machine learning news.
Thank you so much for coming on the show.
Great. Thank you.
People can find me on Twitter at Leo G. Dion. My company is BrightDigit. You can find BrightDigit at brightdigit.com or on Twitter at BrightDigit. Be sure to like and subscribe to this podcast and put in a good review on Apple Podcast, Google Podcast, or wherever you listen. Thanks again for joining us, and we look forward to talking to you again.